So this is another question related to collision and the conservation of the momentum. A student read the following extract from the textbook. In an elastic collision between an object of two equal masses, where one is initially stationary and the object move off at 90 to each other after the collision. The student investigated this using a collision. So if the collision is elastic, then the two objects after the collision, if they have the equal mass and one of them is stationary, it will travel at a 90 degree. So this is shown before the collision, the ball 2 is stationary, ball 1 is moving towards ball 2. And after the collision, you can see the ball 2 is moving. This is the direction in which the ball 2 is moving, and this is the direction of ball 1. In one experiment, using the initial velocity of the ball 1 is 0.72 and the angle theta was 29. After the collision, it can be shown if for such collision, it can be shown that if the balls are separated by 90, then theta v1 is 0.63, phi is 61, and v2 is 0.35. Show that these values satisfy the condition for conservation of momentum in the initial direction of ball 1. Means we want to prove that the momentum is conserved in x direction. So total momentum before collision should be equal to total momentum after the collision. So angle phi is given 61 and angle theta is 29. So this angle phi is equals to 61 and this one is 29 degrees. And the velocities v2 and v1, v2 is 0.35 and v1 is 0.63. This one is 0.35 and 0.63. And the speed at which the initial ball was moving v1 is v2 is there, and this one is 0.72. So this one is 0.72 meter per second. This is 0.35 meter per second. This one is 0.63 meter per second. This angle is phi 61 degrees and this one is 29 degrees. Now we want to show that the total momentum before is equal to total momentum after in direction of ball 1, means x direction. So this will have two components because we need only the horizontal component. So there will be a horizontal component for v2 and v1, and the component which is with an angle, that is written with cosine theta. So this will be equal to 0.35 cos 61, and the other one is equals to 0.63 cos 29. So if we take the conservation of momentum, because we want to prove that the momentum is conserved in x direction, as they mentioned in the question. So we want to prove the momentum is conserved in x direction. So total momentum before should be equal to total momentum after. Momentum before the collision, as the mass of the ball is 60, each ball is 66 grams. So 66 grams, we have to convert into kilogram, which is 0.06 kilogram. So this will be 0.066 kilogram multiplied by speed at which it is moving, 0.72 plus 0. Why 0? Because the ball 2 is stationary, ball 2 is not moving. That's why I put 0 here. That is the total momentum before collision, and total momentum after the collision. So when we sum This will give us the total momentum before. One is 0, the other one is 0.066 multiplied by 0.72. That is 0.0475 kilogram meter per second or Newton second. Then for after collision, the ball 1 and ball 2 will move making certain angle, but their horizontal component will only take the horizontal component. So each ball is having the same mass, which is 0.066 multiplied by speed at which the ball 1 moves. After the collision, so it is equals to 0. You can see here the ball 1 moves 0.63, but we take a horizontal component, so 0.63 cos, and the angle it is making 29, so cos 29. Plus the other ball is also having the same mass, so 0.066, and the speed at which it moved, that is 0.35, but because we take a component here, horizontal component, so it will be cos 61. So when we sum them, it will come out as 0.048 kilogram meter per second. So this is approximately same, like 0.0475 is also 0.048. The two values are approximate. This will be 0.0476, which is approximately equal to 0.0475. The two values are equal. It means the momentum is conserved in x direction. So we just need an x direction. Why we took in x direction, not y direction, as they mentioned in the question, that show that these values satisfies the shows the conservation of momentum in direction of initial direction of ball 1, which is the x direction. Then show that these values satisfy the condition for elastic collision. So for elastic collision, the total kinetic energy before should be equal to kinetic energy after. So ball 1 is moving, ball 2 is stationary. So the total initial kinetic energy will be half mv squared, so it will be half the mass of each ball, 0.066, and the speed at which the first ball is moving. Speed at which the first ball was moving was 0.72. So 0.72 and then whole square. So this will give us the initial kinetic energy before. Then for final kinetic energy, it will be a sum of kinetic energy of ball 1 and 2. So kinetic energy of ball 1 after the collision, half m is 0.066, and the speed at which the second ball is. When we are talking about the kinetic energy, we don't take a component because kinetic energy is a scalar quantity. So we don't need the components here. We just take the final value, the magnitude only. So the magnitude of the first ball after the collision was 0.63 times whole square. This will be 0.00131. And for ball 2, the kinetic energy, which is again half the mass, 0.066, and the speed at which it is moving is 0.35 square. This will give us 0.0040. And when we sum, so 0.00, this was this is 0.0. So when we sum them, it will give us 0.017. So 0.17 after the collision. This is after the collision, the total kinetic energy after the collision is same as before the collision. So it proved then the collision is a elastic collision. If it was an inelastic collision, then the total kinetic energy before will not be equal to total kinetic energy after. Is it clear, this part? Then the next part B. The next question, the photograph shows the student actual result of this experiment, the position of the balls after the collision, a certain time interval. State the additional information that student need in order to determine the speed of the ball. So if a student want to determine the speed of the ball, what he needs. Like example, if student want to determine what speed the balls are moving, so he need, because using the image he can measure the distance, like the scale of the image. If I want to find the speed at which this ball was moving before the collision, so I need distance and I need time. So to know the exact distance, because the image is, so we need the image scale. Like example, 1 centimeter equal to how many meter? So we need the scale of this image. And what else we need? We need the time interval between the images. So using the scale, what does it mean, scale of the image? Like example, different images have different scale. Like 1 centimeter might be equal to 1 meter, or 1 centimeter might be equal to 0.5 meter. That's called the scale of the image. So to determine the speed of the ball, what he need the distance and time. And how he get the distance from the image? He need a scale, the scale of the image. Like what, according to this image, 1 centimeter equivalent to how many meters. So he need the distance, scale of this image, and the time interval between the images to determine the speed of the ball. The student look at the photograph and notice that the angle between the path of the two balls after the collision was not 90. He modeled the collision on a computer. He uses the same initial speed for ball 1 and same value for theta. The computer calculated the total kinetic energy after the collision for a range of values for phi. The following graph was produced. The phi from the photograph, and measure the phi from the photograph and use the graph to suggest why the angle between the path is not 90. So what is the reason why the angles are not 90 degree? Because in the beginning of the question they mentioned, if the collision is elastic collision, then only the angle will be 90. Like student read in the book that in elastic collision between the objects of equal mass, when one is stationary, they will move off at an angle of 90. Like angle between them will be 90 if the collision is elastic. But if the collision is inelastic, the angle won't be 90. So here, using this graph, this is the angle of the phi. On x-axis, you can see the angle phi is given. And what should be the value, or what value we should take? Because using this, we have to determine the total kinetic energy after the collision. So student look at the photograph and notice that the angle between the path of the two balls after the collision are not 90 degrees. So he modeled the collision and he used the same initial condition for ball 1 and the same angle theta. So what was angle theta? The angle theta was 29. So if we use angle theta to be 29 and total kinetic energy after the collision, if I take any other value for phi, like example, I took 50. So if I took 50, What is the total kinetic energy after the collision? The total kinetic energy after the collision is 0.015. But the initial kinetic energy before the collision was 0.017. So means after it is 0.015 and before it is 0.017. So kinetic energy before and after are not same. It means the collision is inelastic. And what is the total angle between them? Because the total angle is a sum of phi and theta. So theta is equals to 29 and phi I took 50. So the sum of the angle is equals to 79. So the angle is 79 and the total kinetic energy is not coming out same. So what is the reason for that? It shows that the collision between the two balls is not an elastic collision. It is inelastic collision. So you can take any value for the angle from 40 to 50 and work out the total kinetic energy. And because the total initial and final are not same, it means the momentum is not conserved. Is it clear, this question? So this is exercise related to momentum and collisions.